Okay, hello everyone. Let's get started. So today we're going to be talking about how it can feel like sometimes when working with Gradle, it's like searching for the holy grail, keeping your build speeds within a certain controllable environment. My name is John Rodriguez. I work on at Square on the Cash App product.
And I'm Rooz. I work at Gradle.
Let's get started. We're going to be talking about our journey in Android developer productivity. And actually, I think you had a story.
Yeah, and so developer productivity, what does it mean? What is it all about? Where it's a few folks, in this case, John, my colleague Nelson, another colleague, Gary Hale, we worked on making the Cash App build as efficient as possible so the 30, 40 Cash App Android developers all become more productive. And in this journey, we will share all the things that we found. And it was interesting, right? I met John in 2017 at the Square office.
Yep,
Nelson was there working at Square. Now he's at Gradle. I know it's kind of confusing.
Yep.
But
our Trojan horse.
yeah, Zach Kay was there. Hans, founder of Gradle, was there. We were talking about optimizing builds. 4 years later, Nelson and I went to John like, hey, let us optimize your builds. I was like, our builds are pretty well optimized. And John, he knows his stuff. I mean, the guy was doing talks on Gradle and the Gradle Android plugin at conferences, right? We're like, okay, but I think, Nelson, we can find some things in his build. And so we pitched him on digging deep, and that's what productivity engineering is, right? To be proactive and not be reactive and look for these things to make everybody more productive, even though folks are not complaining about build times. And so that's what we're going to share today.
Yeah, and in parallel to that, where it started as a small team on Cash App of a handful of developers, grew very quickly. We were very successful before the pandemic. We wanted to grow and double down on our features. And so even if we had decent build speeds before, that would soon turn around, as you all are probably familiar as Android devs. So first, it'll help to understand how Cash App does their builds. Internally, we have it's an open source system, but many people have moved on to things like GitHub Actions or Jenkins. Internally, we have this thing called Kojiku. Like any other CI environment, every time we submit a pull request, it's going to run through the usual KT lint, spotless, unit tests, paparazzi snapshot tests, etc., in order to verify whether the build is successful. This also includes Firebase Test Lab. It also includes some post-processing. So for example, we add pipeline jobs to show test coverage changes or APK stats and changes in our dependency graph. That latter you may be familiar with if you saw Jake's talk at DroidCon Toronto in 2019. He talked about Diffuse, which was a project that he worked on during his time at Google to surface some of those things because of the way that Google does in their internal repo. If you're interested and haven't seen the talk, there's the link, and these slides will be posted after this talk.
So we use some tools here to measure build times, and I wanted to share and talk about some of those. First tool that we used is build scans. And this is a free service that the Gradle team provides. You run your build, and it sends the build metadata to our cloud, and you can see everything that's happening in your build process. We also, actually, John, you want to talk about Assemble Debug?
Yeah, for sure. So if you want to analyze this on your own without necessarily having Gradle Enterprise, which we're going to talk more about later, but just to run a simple build scan, just add the scan option to the command line, and it'll push it to Gradle Cloud. As long as you're okay with some of your data being sent to Gradle servers, you'll have the benefit of being able to see what a build scan is and dive into some of the information we'll go over in this talk.
And you can always delete it if you're worried about sending sensitive data there.
Yep. And also there's a QR code if you want to read up more about build scans.
We also use Gradle Enterprise to kind of measure build times and look at build times, right? This one is a paid service. Many folks use different things, to measure and visualize build times, but that's one of the things that we used. And we also used it to look at, build times on aggregate, right? How are things improving or are things digressing as we're doing these optimizations and things that we found? So this is a tool that we use there. And you can, of course, the QR code here, you don't have to take pictures of it now. We're going to upload all this stuff later. We also use this tool, also a Gradle Enterprise feature called Task Input File Comparison, where we can compare two build scans and see, hey, where are things changing, right? This is what we use to find cache misses in a jar from a third-party plugin or whatnot, right? And you can learn more about that here.
A joke that I made with Rooz and a colleague, Tony Rolick, back in the day is, why would I ever get Gradle Enterprise? It's just a key value store. But that last feature that Rooz showed is actually what won us over. The fact that we're able to compare two build scans, not just for a single developer, but across many members of your team, as we'll see, especially post-pandemic world where distributed cultures, remote working is a lot more prevalent, and people are going to have different build experiences because of that. Being able to compare any 2 points in time and have it stored somewhere is going to be one of the biggest benefits of Gradle Enterprise.
Thanks for the plug, John.
No problem. So some of the biggest wins and findings.
Yeah, so some of the things that we found, right? First thing we found, it was like, hey, the remote build cache was actually getting some negative savings. We'll talk about what that is in a minute. We also realized, like, hey, there was this cache fix plugin. Nelson's doing a talk on that, right? There was getting some negative hits that were causing slowdown in the build, right? And there's no free lunch even on a build cache, right? And we found this wire plugin that had cacheability issues. We found out that the configuration, the way they had set up the remote build cache was not that efficient, and it wasn't working properly. And there was also some unnecessary VPN issues. After we started fixing some of these, we started measuring, and we started realizing this avoidance savings number here. That's what you're kind of looking at here. And this is the remote build cache. This thing started going up. The avoidance savings started going up. So it's like, okay, we're getting excited. It's working, right? And then after a while, once we let the data come in, we're like, wow, assemble, debug build times for CI went down by 50%, right? These numbers, you can see that chart there. The white dots are build times, and it just jumped down by 50%, right, once we had these fixes.
And for those who may not be able to see, like the original time was somewhere hovering in between 13 and 26, so what would that be? Down to around 20 minutes for our worst case. Shaving off half of that, while still not ideal, is a huge jump in improvement.
And we rolled out the remote build cache for all CI, right? And now once things were fully optimized, that's when we started really seeing the value, right? You see here, remote build cache saving around 8 minutes of build execution time. It's around 8 minutes of wall clock savings as well. But what was interesting is, hey, the Cash App does a lot of CI builds. So this stuff adds up. So the total CI compute resource savings within a week came out to 55 days and 16 hours, right?
A teammate of ours, Socket, you may be familiar with him from the open source community, blogged about how we move on Cash App. We merge pretty frequently. Our CI builds, as you've seen, it took up to 40 minutes, but now are kind of down to the 20-minute mark. We merge very frequently. We release every 2 weeks. We release to master even when features are incomplete because we rely on feature flags, and so we aggressively iterate. And so being able to optimize for that using these builds are very important. So let's talk about, so far we've been pretty surface level, right, admittedly. Let's start to dig in a little on how you can optimize for some of your expensive build tasks. So when Rooz started looking at some of the numbers initially at the Gradle Enterprise, he goes, J-Rod, we're killing it. We're doing like really great builds, but he was looking at not just the assemble debug tasks, he was also looking at spotless and smaller like unit test tasks for like your leaf nodes on a dependency graph. And that's great, but the concerns that we always had is what happens when you come in the morning, you pull master, you rebase, and now you're pretty much having to get a coffee because it's gonna take so long. That's the builds that I wanna optimize for, and I recommend that you do the same. So if you're using Gradle Enterprise or build scan analysis in general, don't bother looking at all the tasks. Just hone in on your assemble debug. It's literally the most expensive thing I would hope in your app is because you're building the APK, you're merging resources, you're dexing, you're doing maybe R8. All that crunching takes time, and hopefully in a world where resources go away as we move to compose, it'll get better, but there's no guarantees there. The point is worst case analysis is probably gonna get you better bang for buck. And so the way that we did that, we have a product flavor. So instead of assemble debug, we have an assemble internal debug, which basically is the dev build, and then we also have a beta build, and then finally the prod build we release, which is why you'll see internal there. Your product flavors will, of course, vary. Another benefit is kind of pointing at the joke that I made earlier, like Gradle Enterprise does have a key value store built in where you can tag metadata. We're gonna talk about some of the ones that we added on Cash App to point out certain problems, but just the point is you should be really logging everything. Like the Mac OS, the MacBooks that came out in the last 2 years, they have thermal throttling, as you probably know if you have an intense Gradle build. It was really hard to kind of justify, why are your builds slow, why are mine's not? There was also a blog post that realized wherever you plug in your power adapter on the left side or the right side could also affect your thermal throttling. Who would know that? And so we would do things like checking, like, are you plugged into an external monitor? Because we also had hypotheses that now that you're working from home and you may not be on a desktop, if you plugged into an external monitor, that would also be pulling your battery power and therefore decreasing your overall CPU crunch on a build, which is not what you would think, but during the pandemic, these are kind of things that started to surface as we were all working more from home. And so log, which sounds kind of obvious, but things like whether you're connected to battery power, whether you're, where you're located in the world, which we'll talk about in a bit, just the more data, the better, because when you're trying to troubleshoot someone else's build and you want to enable your engineers to do whatever they want to their machine to be productive, but that conversely makes it really hard to analyze build problems because their environment will not be the same as yours.
And one thing about that last slide, right, those custom values were very helpful to filter down stuff on. Hey, let me see all the builds on this type of OS with these kind of properties. And we can see it on aggregate and see what kind of pains and problems they're having.
A really cool feature that came out relatively recently in Gradle Enterprise is the ability to do critical path analysis. So here's an example build that we had on Cash App. And as you'll see, SQLite and Wire, two plugins that we maintain, were actually causing bottlenecks for us. And so while it's obvious from when your parallelism kind of stops and you have that bottleneck, like for example, if you can see the debug compile, db compile debug Kotlin being the long pole, but for less apparent builds, there's a critical path feature that you can tick on the upper right. And that'll show you basically, in all the things you could optimize, if you optimize this, you're gonna get the biggest return on investment of your time. And so that's a nice feature that I hope to see more investment on the Gradle side.
And I just want to say something, right? This is not just a paid feature. You can get this with build scans today.
You didn't tell me that when you sell it to us?
Yeah, you didn't have to buy it.
Well,
You could have got this out of the box, man.
All right. So let's go a little further. I'm going to assume, how many people here would consider themselves a beginner Gradle developer? Like, I just want Gradle to work. I don't really mess with build scripts. How many people identify with that description? Okay. How many people are like, I can feel relatively comfortable modifying Gradle build scripts to do the things I need to do? Okay, and how many people would say, I'm the ninja of my team at Gradle? Okay, cool. So pretty much in the middle. I just want to basically, I'm going to be talking about like cacheability and things that maybe not everyone would know. So on a very high level, without trying to explain all of Gradle to you, you apply plugins like this, and it's going to add tasks into a graph like this. And so this is a very simple example. If you have a Java library, it's going to hook into what's called these anchor tasks, classes and assemble, and it's going to hook in the ability to compile Java source, and it's going to hook in the ability to package it up into a jar file. Nice. This is a simple JVM library. We don't deal with this type of stuff. We deal with this type of stuff because Android builds are more complicated. Again, you're merging resources. You're not only compiling Kotlin or Java source to class files, you then need to dex them. And so then you have to merge your dexes. Then you have to run R8. Maybe you haven't converted to Jetafire yet, and so you have to transform those tasks. And so this graph blows up out of control. There was a time where Gradle would actually create the entire task graph regardless of what command you were running. If you ran Gradle help, you used to assemble all the Android tasks and then run none of them. And so heap issues became a problem. Gradle has eventually fixed that with something called lazy task initialization and task avoidance, which makes that a lot better. But what does that even mean? So now we have a task. Let's call it the Java compile task. We expect it to have an output of class files. We expect it to have an input of source files. Now, if you write Gradle tasks yourself, this is kind of starting to be a campaign for plugin authors who may be trying to dig into more why their plugins aren't efficient on Gradle. Something that could also affect the task input here is what target SDK you're on. Maybe you moved from JDK 8 to JDK 11 with a recent upgrade to Android Studio. Maybe you're using paparazzi tests, which also require JDK 11. And so that, if you toggle that SDK value, your outputs are no longer to be the same because the bytecode for a JDK 11 compliant is not going to be the same as the JDK 8 compliant bytecode. There could be other task properties like max heap size, But that's not considered an input, because regardless of how much heap I give the compiler, the output class files will still be the same. And so what's important to know is when you're defining a Gradle task, there are many input properties, there are many properties, some of which are inputs, some of which are outputs, and some of which are neither. So why do I mention this? Because Gradle's internal mechanism is all about task inputs and task outputs, and it's important to identify them. When you see something that's up to date or an incremental build, it identifies that your inputs and your outputs have not changed, and therefore you are up to date. Basically, if you ran the run button twice in a row, you should hopefully see as many of these as possible. If you don't, that's a good sign you have a problem. Why would you be recomputing stuff? So going back to this example, if we supply dummy inputs, right now we're compiling a.java, we expect an a.class. If I hit run, I should see in the task list output that it was executed. If I now add b.java, and then I add b.class, I should see a new indication. The inputs have changed, therefore the outputs should change, therefore it's executing again. If I hit the play button again, I should see up to date, right? Because the inputs and outputs have not changed. What happens if we change from A, B back to A? Technically, I did change the task inputs, right? So I should expect the task outputs to change as well. But I did this compilation earlier, and so now instead of seeing up to date or executed, you may see this new thing called cached. If you remembered to echo the caching property at the bottom in your Gradle.properties. And so now we're going to start talking about like why caching is really important and why plugins sometimes don't really respect them well. So,
all right. So speeding up local builds with the remote build cache. This is a really tough one. Already we see just folks using the remote cache for CI, it doesn't crush right out of the box, right? There's all these things happening with your build, and you got to fully optimize it. So build caching in general. It was introduced in Gradle in 2017, right? It's available for Maven and Gradle. And it's not a dependency cache for certain folks that are not aware of this. So the build cache is essentially caching all the steps in your build process. It's like your incremental build cache that you have, but on a local and a global kind of level, where you essentially install this remote shared cache on a server, usually where your CI server lives. CI only seeds this remote shared cache, and developers can benefit from this as well. And how it works is developers come in, as J-Rod was talking about, it's like, hey, what I want to solve is that first build of the day, that first assembled debug build of the day, it's freaking long. How do I tackle this problem? Well, the remote build cache is basically CI is cranking to this thing. Developer comes in to do that first build of the day. Guess what? CI has already built a lot of this stuff. It's in the remote build cache. I'm going to hit the remote build cache. It's going to populate my local build cache and my incremental build cache, so every consecutive build is going to get faster as well, right? Like magic. It should work, right? Well, not really, right? So it's a really tough problem to solve, right? Caching, one of the hardest problems in computer science, right? It's that famous Bill Gates quote, I think. So, oops.
if you want to tackle that one, you can.
No.
Go for it.
So we turned this thing on for local builds, and we started looking at it on aggregate. I'm like, saving around 20 seconds of wall clock time. Can you see that 37 seconds of savings there? But it's not the actual wall clock. Like, it's all right. I mean, 20 seconds is not all that. So we started, looking deeper into, hey, can we get some wins here? So J-Rod came up with this great idea of, hey, let's start tagging the builds so we can look at the builds in the East Coast versus the West Coast, because the remote shared cache server is sitting on the West Coast offices at Square.
Yeah, so a lot of our engineers for Cash App on the Android side were founded in Canada, in Kitchener, Ontario. And since then, we've exploded. I work out of New York. Some engineers work out of Seattle, others in San Francisco. And now we're hiring in Melbourne, Australia. You can imagine what the cache experiences will be for each of those units. So as Rooz mentioned, I figured, let's get some data. Right now, we were using Square Register's cache node because they bought onto Gradle Enterprise 2 years ago. And so we were kind of new to the game, and so rather than, I wanted to hit the ground running and just learning how to optimize our builds. I didn't want to start setting up AWS containers and getting a new cache node going. So we temporarily shared. the register was like, sure, great, but not forever, right? Because most of our engineers are in San Francisco, totally understandable. But I needed to now justify cost. How many cache nodes should we create? And so data, right? You should, if you're gonna spend some good money, you should make sure that there's data to back it up. And so this was our attempt. I mean, as you can see, it's using curl. Like VPNs will clearly work around this, but most people aren't doing this. We just wanted to get a heuristic of how many engineers, what builds are we getting, what their speeds are like, what their internet providers are like, because sometimes they're just not gonna have good quality service. Hopefully everyone has FiOS, but not everyone does. And then so one of the things about Gradle Enterprise is everything's bookmarkable, right? It uses a REST API that's very filtered, configured, properly designed. And so things like this, being able to see what your trends in different time zones are, as well as looking at certain properties, are helpful. For example, there was a time where VPN was down at the company. It has nothing to do with Gradle, just we had an outage. And so me enforcing the property, there was actually many things at play. We had a VPN, you have to be VPN'd in order to pull from Gradle cache. But there are other reasons in our code base where you don't need to be VPN'd, and so now there's something you have to remember. Oh, when I want to do Gradle builds, I need to be VPN'd. That's not something one is going to remember. And so one of the things that we did was basically check to see whether you're connected to a VPN, and if not, fail the build, because we are pretty much going to give you a bad build experience now that we have this remote cache that you're not connecting to. And so one of the things I would do is audit to see who has this flag on or disabling that, because if someone says, oh, my build's not working, I don't know why it's so slow, it's like, oh, you probably disabled this flag. So again, it's kind of like big brothery, but it's helpful to know like what everyone's dev environment is like, so that when you triage the builds, you have all the data necessary.
And the pandemic made this problem even harder to tackle, right? Folks are working from their aunt's house or Starbucks or whatever. Now they got to hit this remote cache server from Starbucks in whatever, Canada, and this cache node server is sitting in California, right? What is that going to be, right? So after we did the optimizations and JRod got the tagging set up, we first started looking at East Coast builds, right? We started looking at New York builds, and we realized, well, hey, this remote build cache savings kind of went up on aggregate, right? Now it's build execution time, 1 minute and 12 seconds saved per build, and these are assemble debug builds. These are the expensive builds, because when you looked at it on aggregate, it wasn't that exciting. But once you look at these big expensive builds, that first build of the day, or when you change branches or change projects and your cache is empty, that's when the remote cache comes in to help kick things in, right? But wall clock time, it wasn't bad, right? 38 seconds. So we're like, all right, well, what's California like? Whoops. So then we looked at California. It's like, okay, wow, we got something here. And as you can see, right, you see these gray bars? You're not always hitting this remote shared cache. It's expensive, right? But when you need it, when your cache is empty, this thing is going to come through, in some cases saving a lot of time. And on aggregate, when you take the averages of it for California, was pretty good, around 3 minutes, 41 seconds of build execution time. This is per build for assemble debug in California, and wall clock time around 3 minutes and 10 seconds of engineering time saved per build. Now it's like, okay, we're getting somewhere. This is now exciting. So we said, hey, hypothetically, right, how do we convince upper management to set up a cache node in the East Coast, and maybe even other places? So we have some interesting data, and that's what we found, like just productivity engineering in general, right? Once you have the data, you can actually help prioritize certain things. Hey, should we be using this annotation processor that's killing this much time? Well, now you have some data behind it. So we started to use that same concept. Realized, hey, the difference in wall clock time in remote cache savings between New York and San Francisco was around 2 minutes and 12 seconds per build, right? East Coast assembled debug builds, right, around 709. Cash App does a lot of assembled debug builds from local machines per week. They do around 1,400 and some change per week, right? Most folks are on the East Coast, right? So around 709 of those. And then, so what would that result is, you do the math, you got around 1,500 minutes of saved engineering time per week if we had a cache node in East Coast, where East Coast folks could get the same numbers as the San Francisco folks, right? You multiply that by 48 work weeks per year, you got around 1,200 hours of engineering time saved. Then you multiply that by what a Cash App Android developer makes in the US, right? Now we're talking big money, right? It's definitely way more expensive than the cost of setting up a cache node in the East Coast. So there's your business justification study.
So let's talk about now modularization. Many times engineers on Android avoid modularizing their app because there are perceived cost setbacks, for example, configuration. Who's identified with this? You have everything in your app module and you're like, oh, the engineer in me knows this is bad. I should stop having everything in app module. Let me modularize. And then you go, what the hell? Now my build speeds maybe sometimes are better, but my configuration time went up. And so that can sometimes be a deterrent rather to move forward to modularize. I'm going to say that now is not the time. Now is a good time to rather move past that and to still move forward and modularize. And part of the reason for that is configuration caching, which we've yet to talk about, is coming up. And configuration caching is a feature that will minimize this time. Also, the cost in your builds by modularizing goes severely down if you use things like Dagger. Capped, in particular, is very expensive, but when you have really small modules, its impact is very small. On Cash App versus the register team, we have different Dagger setups. On the register side, they heavily use subcomponents, and so build times were affected on the granular module level. For us, we have 2 or 3 components that all live in the app module, and everything down from there in the feature modules are really modules and injection sites. And so the factories that are generated in those small features are pretty small. And so if Capped only has to compile a presenter factory and a view factory on a small module basis and you're caching it, your build times are actually going to be really small. Capped can be cacheable in those cases. And so I think that's the greatest argument to modularizing your app to benefit from that. We've also seen on Cash App when we try using Anvil, we've had worse build times, whereas Register has posted that they've seen improved build times. In fact, I think Zach Swears on Slack also blogged that Slack has seen improved build times. And so the TLDR there is your mileage may vary, but modularization is almost always the key benefit, because if you keep your modules small, as you see, we have 590 modules, and some of them are YouTube modules, some of them are integration modules, some of them are feature modules, and then finally you're going to have your demo apps, your big app module. And so most of the time is going to be spent DEX merging in the app module. All your other, and if you use sample apps or demo apps, you can bypass a lot of that. So hopefully I've given some sort of convincing argument that modularization should move forward. And as I mentioned, the configuration cache is going to help with the rest of that.
And it's a new feature. You got to be on Gradle 7, AGB 7 to kind of try this out. We have a few customers using it. And essentially how this thing works underneath the hood is, you know, when you have a lot of modules, right, your incremental build cache, these up-to-date checks are going around every single one of these modules, kind of saying, hey, what has changed, what hasn't changed. So we're essentially caching the configuration phase. And the results have been pretty amazing. Whoops. They've been pretty great. We have a few folks on pretty large apps trying this thing today. And you kind of see, hey, the baseline without configuration cache, with configuration cache, some great results. Gradle build tool team is, of course, dogfooding it as well.
And so the big apps that Rooz mentions tend to be like your Ubers, your Squares.
Yeah.
Any others that you can mention?
Yeah, Seller is using
Register, yep.
Yep.
Cool. Ultimately, as you dig down this rabbit hole, you're going to see that a lot of the problems don't exist in your app. They exist on dependencies that you use a lot. So let's talk about how you'll track down some of those and how we did. I mentioned SQLite earlier. For those of you who aren't familiar, it's an alternative to Room where you can generate type-safe APIs in Kotlin for your SQLite databases, your manager objects. And so in March, well, this says August, but I know that since March we've made a lot of improvements to the plugin, either internally or we've had community support. For example, there's a test migration task. One of the nuances of task inputs and outputs is if you write your own custom Gradle plugin and your task has no outputs, you will never be considered up to date. In other words, you will always run that task. And so the verify migration test was essentially a JUnit test assertion. It didn't have any output. It either succeeded as expected or threw an exception. And so that was actually terrible because when it succeeded, it wasn't caching its output, and so we always ran it. And as your database schemas grew, this verify migration test took a long time. And so it was nice that we were able to catch that. And so it's like, okay, you want to pay the cost heavy. You want to make sure your database schema has, integrity. But you don't need to run it multiple times if it's never changed, right? That's the whole point of Gradle caching. And so we were able to catch that and improve on that. And there's more detail there that you'll see in the slides. Basically, add a dummy file. That counts as an output. Yeah, sometimes it'd be that way. Another thing is fixing the Gradle build caching in general. One of the nuances that we didn't talk about before, whether you're using local cache, well, actually, not when you're using local cache. This comes up more when you're using remote caching, is that how do you reference the files that you're touching in your cache? So if it's under users jrod/foo, that's fine as long as it's always under users jrod foo. But now if I move it to users Rooz foo, well, he doesn't have users jrod foo. So he's always going to get a cache miss, even though the relative path was foo and could have avoided a cache miss. And so a lot of the plugins that you'll see are starting to fix that now in order to support remote caching and work well. And Gradle Enterprise has actually helped us suss that out. You have to think in a relative path world. So SQLite also had that issue, and Paparazzi, and we fixed that. Another thing which I'll touch on is there is a lot of still antiquated Gradle code out there that should never be written. I mentioned earlier when I was talking about that task graph, this huge task graph is built, but it really doesn't need to create everything in memory. So one way to do that is to use lazy deference. It's like configure each says, don't create the task, but when it is going to be created, set these values on it. And so that pattern helps save some time. And then with configuration caching, one of the things that configuration caching needs to work is you can never refer to project in your task action. So when you run your task, you can't have any handles to project. Unfortunately, a lot of plugin authors relied on project, either to look in the manifest and get some metadata or to just get the project name for logging. The simple workarounds are to just take those properties earlier, not in the task action. You can use like essentially providers, which are like lambdas, to basically get the closure block that will execute the data when you need it, but without having an explicit handle to project, which is essentially configuration caching relies on serialization, and it can't serialize the project object. And there's more detail on that in the Gradle docs. So SQLite was released. Similar things for Wire. I'll just breeze through this because I think we're running a little behind. Zach Swears made a really clutch contribution recently to make configuration caching friendly on Wire, and we also have a release on that as long as you're okay with trialing in alpha. Wire is a protocol buffer project for those who aren't familiar. If you're using JSON APIs, you may not ever deal with Wire, but if you use protocol buffers, Wire is an option. And then also some handiwork by Nelson and Gary, members of the Gradle team. So it turns out that task inputs and task outputs and cacheability sometimes isn't great. For example, when you're using remote cache, sometimes the I/O savings that you download all these dependencies from your remote cache is actually slower than crunching it on your local CPU. It seems weird, but it can matter, especially when you're doing things like merging of resources. And so the Android Gradle plugin, depending on every time you bump versions, it may add tasks, remove tasks, and the point is you're not supposed to care. Tasks are implementation detail. You just want the plugin to do its job. So what the Gradle team has done is they figured out based on heuristics which tasks do not benefit from caching. Eventually they tell the Android team and they'll make the task uncacheable, but in the interim, if it is cacheable and it's having negative cost savings like we talked about before, you can disable that. Again, avoidance savings is simply the difference between how long it would have taken it to run locally and how long it would be from the cache. For more details, Nelson's given a great talk on this tomorrow. Go see it. So let's fast forward to best practices for build performance. If you're a plugin author, you hopefully are familiar with what Gradle Test Kit is. It helps you write integration tests against your plugins. Even if you are familiar with it, I would bet that many plugins in the wild haven't been keeping up with their tests to implement known Gradle feature sets. For example, the cacheability feature in Paparazzi hadn't been caught. And so we right now test for every single Gradle feature so that we don't regress accidentally. You add a new property, but you forgot to cache it. Now this test will fail, which is great because otherwise I'm not going to think about how the Gradle contract works. I'm going to worry about making my plugin ship. And so this is a nice little fail-safe like tests usually do. Same thing for configuration caching. So now anything that gets committed to Paparazzi project or whatever plugin project this may be will run configuration caching. Another thing, don't use create. Don't use task.create anymore. Only use register. Why? Well, if you look at the method signatures, you see one returns a task, one returns a task provider. A provider is a lambda. It's lazy. If you don't use the lambda, you're always creating that task. Remember that big task graph that you want to avoid and you want to defer the initialization? To do so, you must use the last method. Now, that may not be entirely obvious. And part of the reason for this is that, unfortunately, Gradle doesn't deprecate their APIs nearly aggressively as they should. I attempted to submit a PR to fix that. And while I'm optimistic that it will eventually get done, it was not merged immediately because they want to clean up some internal housekeeping first. But the idea is like, if APIs should not be used, they should be deprecated or removed, right, Gradle? Upgrade. I know, alphas and betas are scary, but you as an Android developer are depending on Gradle, Kotlin, and AGP. And so if you wait for their 6 to 12-month release cycles to finally touch it, you're not gonna know what changed, and your build speeds may suffer, and you don't know why. And so the way to get around that is just have a CI job, a work in project, a long-lived branch that you just keep for 6 months out there while you're working your important stuff, but just look at what breaks in your build and see what performance regressions occur. And one way to do that is by using the Gradle profiler. One thing you can do with the Gradle profile is set benchmark regressions. You can set up scenarios where you're saying, hey, how long does my APK build take? And just have it like on instead of every pull request, have it like on a nightly job and graph that. And see like, hey, I just innocently bumped AGP. Why did my build times increase by 2 minutes? You wouldn't have caught that unless you ran this benchmark. And why would you think to? But with the Gradle profile, it's actually easy. So use it. We haven't used this yet for much on Cash App, but we're gonna be doubling down on that because we can't keep up with every plugin version in perpetuity. Remember when I showed you this earlier about modularization? Yeah, you really should do that. You're gonna benefit from it. As the performance shows here, configuration caching should make the known detriments of modularization go away. Use build scans. Whether you decide to invest in Gradle Enterprise, that's up to you, but build scans are free. They're helpful. The only thing you won't get is the ability to compare two build scans, right?
Yeah.
Okay, but having a single build scan is better than nothing. It's gonna surface a lot of data.
And you can use the data on spreadsheets or whatnot if you want to visualize it.
Some other things I mentioned for your remote build cache, make sure that you check that they're connected to whatever they need to be connected in order to benefit from the remote build cache. Otherwise, your numbers and your developer experiences will suffer and you won't understand why. You're like, wait, we spent all this money on a remote cache. Why are your builds not working? But still give them a flag to opt out in the cases where some things are out of your control. Another helpful thing, a lot of these plugins have these magic properties that maybe they document, usually they don't. And so you can suss these out. Just log all the properties. They usually use a convention. And so now you can see if one engineer on your team decides to be experimental and it has either positive or negative impacts, now that data is getting logged to Gradle Enterprise. So you can say, oh, so-and-so, what made you do this? What was your experience? Or better yet, just compare the build scans and see for yourself before you promote it to the actual Gradle properties in the project root. Again, surfacing information, nothing too crazy. And finally, even if you do all this, sometimes you just won't get great builds. And I'll tell you why. I picked on Gradle before. Now I'm going to pick on Kotlin. In 2019, I gave a talk with a teammate, Igor, about taming the Kotlin compiler. And while I won't go all over that, remember the whole thing that Rooz said earlier where in the morning you pull from master, rebase your branch, and then push, and you should get all the benefits of remote build cache? Turns out that's complete bullshit because Kotlin does not honor build cache restoration when you do incremental compilation. This bug was filed 2 years ago. I initially filed it with Gradle and Kotlin because I really didn't know who was to blame. And one of the senior Gradle engineers quickly let me know, no, it's not us, it's them. And so I follow up with them. And yeah, follow that link, star it, rant. Please let JetBrains know this cripples the entire Android community. And they have not done anything about it in 2 years. This is the line that is affected if you want to go really nerd out on it. That whole thing, local state's bad. It breaks caching. Cool.
All right, 30 seconds. So if all this stuff is way over your head, you're like, what the hell? How am I going to remember all this crap? All right, here we go. The essentials. One, build scans.
Blame Gradle. No, I'm just kidding.
Build scans. They're your best friend. Use it. You're going to get a lot of data under there. There's a lot of training and content around it. Make sure you're using the daemon. Make sure you're using parallel. Make sure you got max workers. Make sure you got configuration on demand. This one team is like, hey, I got a 4-core machine. Well, you're using only one worker, right?
One caveat, Max workers, if you do video conferencing, we'll suck up all your eCPUs and you won't be able to join a Google Meet or do pairing. So maybe Max workers -1?
So the essentials, level 1, you got to get that local cache going. You can check out your build scans. You can check out your Gradle property to make sure you're kind of doing this. This should be doing stuff. I guess it's not. Level 2, funnel watching. What is this thing? No, it's supposed to have this nice animation here. Level 3, remote build cache. And finally, for large builds, you got your configuration cache.
So the file watching benefit is basically Gradle can watch your file system ahead of time and make heuristics ahead of time so that it doesn't have to wait till the build occurs, and so you can get some benefits that way. For example, if you're touching a source file, but all you did was add a comment, you probably shouldn't invoke Java C again. So Gradle will try to get ahead of that.
And that's turned on by default in Gradle 7 and AGP 7. And that's it, folks. We'll be around for questions. We're a little bit over time. We also have a Gradle booth. You're welcome to come there. We got some really cool Gradle t-shirts like this one. And yeah, thank you.
Also, a quick plug, I gave a talk about Paparazzi, a snapshot library, a week ago in Berlin. I think there are some available slots, so I may be giving that talk again here in London. I just don't have a confirmed time yet, but if you are interested in learning how you can do snapshot testing without ever needing Espresso, Roboelectric, or an emulator, and just need pure JVM, please attend that talk. It's a pretty innovative library.
Do we have time to take questions here, or we're way over?
Way over, 2 minutes over, it's fine.
2 minutes over,
Let's,
we're ready to take some questions?
just chat with us here on the side,
Yeah.
Thank you.
Cool, thank you, guys.